Dear audience, welcome back. Today we are going to learn the multiplication of two matrices. To do the multiplication of the two matrices, first of all we have to know that when is it conformable for multiplication. That means two matrices A and B are conformable for multiplications if the number of columns of the first matrix is equal to the number of rows of the second matrix. Again, I repeat, the multiplication of the two matrices is possible when the number of columns of the first matrix, again I repeat it, the number of columns of the first matrix is equal to the number of rows of the second matrix. To clear this fact, we can take an example. Here, the first matrix, the number of columns of the first matrix is 3. 1, 2, 3. And the number of rows of the second matrix is 3. So the multiplication between these two matrices is possible. But how will we do it? To do it, first of all, we have to consider the first column of the second matrix. First column of the second matrix. Then we have to multiply all the entries of the first column of the second matrix by the corresponding entries of the first rows. Then adding those product we have to put along the first column. Similarly, we have to multiply all the entries of the first column of the second matrix by the corresponding entries of the second rows of the first matrix, and adding those products we get products we will find a sum, and we have to put that sum here. Again, we consider the second column of the second matrix. Now multiplying all those entries by the corresponding entries of the first rows of the first matrix, and adding those products, we get sum and put it here. Again, we multiply all the entries of the second columns of the second matrix by the corresponding entries of the second rows of the first matrix, and adding those products we get a sum and put it here. Now we have to multiply all the entries of the third column of the second matrix by the corresponding entries of the first rows of the first matrix, and adding those product we get a sum and we put it here. Again, we multiply all the entries of the third column of the second matrix by the corresponding entries of the second rows of the first matrix, and adding those products we get the sum and we have to put it here. And it can be shown in the screen. Suppose that here, if we multiply all the entries of the first column of the second matrix by the corresponding entries of the first rows of the first matrix, we get A11, B11, A12, B21 plus A13, B31. Now adding those, we get a sum. That sum is the A11, B11 plus A12, B21 plus A13, B31. Again, we multiply all the entries of the first column of the second matrix by the corresponding entries of the second rows of the first matrix. We get A21, B11, A22, B21, A23, B31. Adding those, we get A21, B11 plus A22, B21 plus A23, B31. Now, again we have to multiply all the entries of the second column of the second matrix by all the corresponding entries of the first rows of the first matrix, and we get A11, B12 plus A12, B22 plus A13, B32. Now we have to multiply all the entries of the second columns of the second matrix by the corresponding entries of the second rows of the first matrix. Then we get A21, B12 and A22, B22, A23, B32. But we have to multiply, we have to add all of those products. Then we get A21, B12 plus A22, B22 plus A23, B32. In this way, second column of the product matrix is formed. Now we have to make a third column of the product matrix. To do that, we multiply all the entries of the third column of the second matrix by the corresponding entries of the first row of the first matrix. Then we get A11, B13, A1 plus A12, B23 plus A13, B33. Again, we multiply all the entries of the third column of the second matrix by the corresponding entries of the second rows of the first matrix. We get A21, B13 plus A22, B23 plus A23, B33. And adding those, we put the sum here. In this way, we can do the multiplication of the two matrices. Now, let's have a look on an example. Here, an example is given. If A equals 1, 2, 3, minus 2, 5, minus 1, 2, 3, 4, and B equals minus 1, 5, 3, 7, minus 2, 1, 2, 0, minus 3, then we have to find the product of each. To do that, first of all, we write AB equals these two matrices. Now, what should we do? Here, first of all, we have to multiply 1 and minus 1. Then we'll have minus 1. 2 and 7, that means 14. 3 and 2, 6. Minus 2, minus 1, that means plus 2. 5 into 7, that means 35, plus 35. Minus 1, 2, that means minus 2. Again, we have to multiply all the entries of the first column of the second matrix by the third rows. And the third rows is the 2, 3, 4, and the first entries of the first column of the second matrix is the minus 1, 7, 2. So multiplying 2 and minus 1, we get minus 2, 3 and 7, 21, 4 and 2 is plus 8. Now we have to multiply all the entries of the second column of the second matrix by the corresponding entries of the first rows, second rows, third rows of the first matrix. So multiplying 1 and 5, we get 5, 2 and minus 2, minus 4, 3 and 0, plus 0. Minus 2 and 5, minus 10, 5 and minus 2, minus 10, 1 and 0, plus 0. 2 and 5 is 10, 3 and minus 2, minus 6, 4 and 0, plus 0. Now again we have to multiply all the entries of the third column of the second matrix by the corresponding entries of the first rows, second rows, third rows of the first matrix. Then we get 1 and 3, 3, 2 and 1 plus 2, 3 and minus 3 is minus 9, minus 2 and 3 is minus 6, 5 and 1 plus 5, minus 1 and minus 3 is plus 3, 2, 3, 6, 3, 1 plus 3, 4 minus 3 minus 12. Now doing calculation we get here the 19, here the 1, here the minus 4, here the 35, here the minus 20, here the 2, here the 27, here the 4, here the minus 3. This is the product of the two matrices. Dear audience, I hope that you could understand today's lesson. Again, I will come along with a new video tutorial. Till then, goodbye.